In section 8.2, we're going to use place value to convert fractions to decimals. So notice all of these fractions have denominators that are base 10, but we might not necessarily, so for example with 32 tenths, okay, we don't start immediately in the tenths place because 32 is larger than 10. Okay, so let's take a look at these. Okay. So the idea is 27 hundredths. They've seen this before, and we think of the hundredths as the place value where this number needs to end. Okay, so they could either do this backwards, 27 hundredths. Okay, here we have 145 tenths. Okay, so it will end in the tenths place. And we want them to see that 145 tenths is equivalent to 14.5. Okay. Then there's some other ones that are more typical that we've seen before. 423 hundredths. So if we end in the hundredths column, that would end here. Okay. Or you can, instead of using this backwards idea, you can say you want it to end in that column. There's 3 digits, so we'd go start 1, 2, 3 digits to the left of that column. And then in 8.3, we're going to use factoring to convert fractions to decimals. So now, instead of long division, we'll have denominators that whose prime factorizations are all 2's and 5's, so they're going to terminate. Okay, and we're going to have them rewrite these with denominators that are powers of 10, and then place the results in the place value. So let's look at these in the place value chart. Okay. So for 3/4, we can think of this as 3 over 2 times 2. Okay. To make the denominator products of 10, okay, we need 2 factors of 5. Okay. And then you may want to reorder these so they see this better, but 2 times 5 is 10, 2 times 5 is 10. And then 25 times 3 is 75. Then we have 75 hundredths, and we'd place that in the chart like this. Okay. The same idea will work for these with 3/8. We'll see that we have 3 factors of 2. And this also shows them how far the decimal is going to go out if they see this pattern. Multiply it by 3 factors of 5 in the numerator and denominator. Okay, so this would be 3 factors of 10, which is 1,000. This is 125 times 3, which is 375. So this would be 375 thousandths. Okay, so to sum up, we took fractions. First we used decimal grids and shaded a denominator number of pieces out of every, or numerator number of pieces out of every denominator number of pieces. Then we said, hey, let's look at fractions with denominators of 100 and see how they connect to the place value chart. And then we said, okay, now we have, going back to fractions that do not have denominators that are powers of 10, let's rewrite them as powers of 10 and put them in the place value chart to connect them. Okay. And then we want them to see the idea of rational numbers, but whose decimals that do not terminate. So let's look at, how about, let's look at 8/11ths. That one's a little trickier. Okay, so we want them to shade 8/11ths, and we want to approximate it to 4 decimal places, and we know we have the zoom here. So the denominator cannot be, its prime factorization is not a product of 2's and 5's, so we know this is going to repeat. So we want them to see this repeating idea. And the previous one, 1/3, is easier for them to see, but I thought I'd do this one first. So first we want 8 out of every 11. Okay, and this can be tricky to shade. I remember having to do this twice when I did the video. So Here, let's take the 11 as, how about this row and this one right here. So we'll shade 8. Okay, and then I'm going to X out the ones I'm not shading because this can get messy. Okay, now here's 9, 10, 11. So I'm going to shade 8. Oh, and X out the 9, 10, 11. Okay, I'm assuming you're getting the gist. I'm going to pause and save you the pain of watching this. So I continue to go through, shade 8, and then X out 3. And notice, if you did this, you might want to try this on your own, you'll end at 99. Okay, so there's 11, so we're going to take 9 groups of 11, and each of those 9 groups will have 8 of them shaded. So you can count these, or we have 9 times 8 is 72. But then we have this last one. So what do we do with this? Okay, so it's easier with 1/3 on the previous page, but you need to convince your students, well, here's this. I changed the zoom grid to look exactly like this, okay, but smaller, okay, and that they'd follow the same process. So they'd shade 8 out of every 11, and they'd get the same exact picture with this one left over, and they could repeat that forever. So the idea is for them to see that this was 72/100th shaded. If they did this again, the columns are thousandths and the little ones are 10,000ths, so they get 72 again, 72 again, etc. Okay, so they can put that repeating pattern in here, and then they're asked to approximate to 4 decimal places, so 1, 2, 3, 4, and we'll round up to 0.7273. Okay, so this is really nice for them to see a different way besides long division of seeing why the decimals repeat forever and ever. Okay, but eventually, you know that for a lot of these types of fractions, if we wanted them written as decimals, we would likely not do this by hand. We definitely wouldn't shade a grid. Okay, we want them to have that understanding, but the main skill they're going to need is putting this on in a calculator, being able to round appropriately. Okay, so now that we've established those ideas, we have them approximate fractions that will have repeating decimals that don't terminate and round them to different place values. Okay, notice we have negatives in here, and you'll want to teach them either that they can leave out the negative and just put it at the end, or how to put these in the calculator. Okay, in the next video, we'll look at converting decimals to fractions.